Welcome, and thank you for joining today's special virtual event, Investing in a Healthier Future. We've assembled an extraordinary group of experts and are honored to have President Clinton deliver today's keynote remarks and frame our discussion focusing on the record of the National Institutes of Health, including the Human Genome Project during his administration. President Clinton's interest in, commitment to, and long-term significant investment in the NIH helped lead to a range of initiatives that, building on prior efforts, have had a significant positive impact since then and will continue to do so long into the future. And this investment in biomedical research is reflective of President Clinton's commitment to spread broadly the benefits of science and technology. Our first panel today, focused on the overall record of the NIH, will be moderated by Secretary Donna Shalala, and the panelists include Dr. Harold Varmus, Dr. Tony Fauci, Dr. John Gallen, and Dr. Gary Nabel, each of whom served at the NIH during the Clinton administration. Our second panel, focused on the Human Genome Project, will be moderated by Dr. Varmus and includes panelists Dr. Francis Collins, who also served at the NIH during the administration, Dr. Wendy Chung, and Dr. Charles Rotimi. Thank you to our participants for their extensive contributions over careers that have enhanced health, lengthened and improved the quality of life, and reduced illness and disability, and for taking the time to share their insight and expertise with us today. This event is brought to you as part of the Kumpuris Distinguished Lecture Series, established through a gift from the Kumpuris family. The lecture series is presented by the University of Arkansas School of Public Service, the Clinton Foundation, and AT&T. Today's program's closing remarks will be given by Victoria DeFrancesco Soto, Dean of the University of Arkansas Clinton School of Public Service. Before we begin the formal program, I'd like to briefly mention the work of the Clinton Foundation. You may be familiar with the efforts of the foundation over the years, such as the groundbreaking work through the Clinton Health Access Initiative, or CHI, that has saved millions of lives and reduced the burden of disease in low and middle income countries through various strategies, including by increasing access to and reducing the price of medicines for HIV/AIDS, among other diseases, by partnering with the American Heart Association to address the epidemic of childhood obesity through the Alliance for a Healthier Generation, and in creating a truly innovative approach to partnership and philanthropy with the Clinton Global Initiative, or CGI. Today, the Foundation's work continues through programs that aim to create economic opportunity, improve public health, inspire civic engagement and service, and highlight the record of the Clinton administration through what we refer to as Project 42, of which today's program is a part. And my thanks to Laura Marcus, who is leading that effort. And our work also continues through CGI, which brings together representatives from the public, private, and not-for-profit sectors to address the world's most pressing challenges. As you may have seen a few weeks ago, President Clinton announced that we'd be launching a reimagined CGI annual meeting, which will be held this September in New York City. And the heart of the Clinton Foundation is the Clinton Presidential Center, home of the Clinton Library in Little Rock, which, since its inception, has been led by Stephanie Street, my good friend and colleague, which has been integral to today's program. Since opening in 2004, the Clinton Center has welcomed over 4.9 million visitors, engaged more than 460,000 students and educators in its offerings, and is also home to the Presidential Leadership Scholars Program, a partnership with 3 other presidential libraries focused on outstanding mid-career professionals. Thank you again for joining our virtual program today, Investing in a Healthier Future. Now, Mr. President, I'm pleased to turn the program over to you.
Thank you, Kevin. Thanks for all you've done, especially during these tough COVID times at the Foundation, and for all we are about to do. And thanks for the 8 years you put in at the Department of Health and Human Services. I want to thank Stephanie for spending more than half of her life with me now. She was barely out of college when she came to work in the White House, and she's been great at the Presidential Center. And I want to thank all of you who are responsible for the Kumpuris lecture series, especially Dean Kumpuris, Drew Kumpuris, Catherine Ann Trotter, for endowing this series in their parents' names. Frank Kumpuris was one of the most respected doctors in our native state. He and his wonderful wife, Kula, raised a great family and made the world a better place. And so I expect his children, coming from a family of doctors, including Dean and Drew, this edition and having all of you here is especially meaningful. So to the panelists, I can't thank you enough for doing this. Thank you to Donna Shalala, who I think still is the longest serving Secretary of Health and Human Services ever. She managed to fit that in between being president of Hunter College and chancellor of the University of Wisconsin at Madison, and then her long tenure at the University of Miami, where she now teaches. And she did a stint as the most overqualified member of the United States House of Representatives. Thank you, Harold Varmus, for all the work you did when I was president. Thank you, Francis Collins, for many things, but overseeing the international effort to sequence the human with Craig Venner and the private sector effort to turn a race into a relay. Thank you, Tony Fauci. I'm amazed you're still standing after all you've been through these last 2 years. And I was always grateful to you for your hard work, and never more grateful than to see you trying to talk common sense in the middle of nonsense. You have been great. Thank you, John Gallen. Thank you, Gary Nabel. Thank you, Dr. Wendy Chung and Charles Rotimi. I'm grateful to all of you. This program is very, very important to me because the efforts we made to advance the cause of science, especially in health matters, is one of the most important things I did as president that I didn't grab any headlines. I'm proud that we had 8 years of growing prosperity and more broadly shared. I'm proud of the work we did for peace around the world. But we all should be living in the present and for the future. And you spend every single day of your lives doing that. And for that, we should all be profoundly grateful. The NIH is a national treasure. And it had received, even in the polarized times in which I governed, we had an astonishingly broad base of bipartisan support at the National Institutes of Health. I came into office when we were entering the information age. The whole revolution, in part, made possible the sequencing of the human genome, which obviously required massive digital capabilities. There's always been a tension in every budget season, and we saw it with President Biden's recent budget, between the present and the future. Always a tension between what is too little and what is nowhere near enough to sleep comfortably at night. I'm very glad that we could double the budget of the NIH almost, and more than triple the budget of the Human Genome Project. I think that it's clear that the work that was done helped to speed the development of antiretrovirals for HIV/AIDS, did important work in vaccine research and established the Vaccine Center, which I think hastened our ability to develop the COVID vaccine, especially with the completion of mapping the human genome. I spent $3 billion of the American taxpayers' money on that. And we had the first rough draft in 2000. And I tell everybody that it's the best $3 billion I ever spent in my life. We had a return on investment of something like 300, 400 to 1 already, and an incalculable impact on the future prospects of life. Let me say one more thing before our panel starts. One of the reasons the NIH accomplished as much as it did is that so many people with extraordinary talent and dedication chose to work there, and at the Department of Health and Human Services, and in the White House, all pulling in the same direction. Most of them could have made more money doing something else, but none of them could have made a bigger difference doing something else. So all of you are, by definition, difference makers. We were talking before the program started about our friend Madeleine Albright. And the last conversation I had with her, I sort of began by asking about her health. Her voice was strong. Her mind was clear. She said, look, I'm not well, but I've got a good doctor and I'm doing what I'm supposed to do, and it'll either work or it won't. Let's not waste time on that. The only important thing is, what kind of world are we going to leave to our grandchildren? And we proceeded to talk about that. Every day, every step of progress you make, every blind alley you run into and then turn around and try something else, helps us in ways that are not always clear to keep going forward and to keep proving that, in the end, the most important discovery of the Human Genome Project is that all non-age-related differences we can see among human beings are rooted in less than 0.5% of our genome. And sadly, the world gets in trouble when we major in the minors and only talk about that 0.5%. We spend 99.5% of our time fixated on our differences. And when we're in a foul humor, we completely forget about the other 99.5% of us that is the same. By using your different abilities, by making your diversity of intellect, imagination, and effort a virtue, you reaffirm the fundamental sanctity of life and all of humanity. I'm very grateful, and I can't wait to see what you have to say. Thank you very much.
Thank you, Mr. President, for those remarks. As we transition to our first panel, let me introduce Secretary Donna Shalala, who before becoming Secretary of HHS, served as the Chancellor of the University of Wisconsin, one of the nation's top research institutions. Donna?
Thank you very much, Kevin. And thank you, Mr. President. As Kevin noted, I came to HHS in 1993 from a major research university, the University of Wisconsin at Madison. And during those years, I also sat on the NIH Advisory Committee to the director appointed by Secretary Sullivan. I've always believed that the president's most important legacy was his commitment to science, to the NIH in particular. There'll be lots of references, and he made one of them, to bipartisan efforts to successfully almost double the NIH budget, which unleashed a golden age of biomedical research. But for me, it was not just the doubling, but what the leadership did with that money. First. Second, it was really the leadership we recruited and those we retained, and the impact of training grants on preparing a new generation of scientists. Today, we're going to hear from some of those leaders, and I'll introduce the four for my panel, starting with Dr. Harold Varmus. Dr. Varmus, of course, won the Nobel Prize with his colleague Mike Bishop in 1989, the Nobel Prize in Physiology or Medicine. He was director of the NIH from 1993 to 1999, and he came back to lead the NCI from 2010 to 2015. Dr. Tony Fauci, director of the National Institute of Allergy and Infectious Diseases, and now the chief medical advisor as well to President Biden. And of course, our leader during the Clinton administration in an extraordinary effort against AIDS. Dr. John Gallen, director of the NIH Clinical Center, actually from 1994 to 2017, 22 years, John Gallen led the very critical clinical center named for Dale Bumpers. Currently, he's the chief scientific officer for the Clinical Center and associate director for clinical research at NIH. And Dr. Gary Nabel, who was recruited to build a vaccine research program for the country. And I really made a mistake. That's named after, the Vaccine Research Center is named after Dale Bumpers. He was the founding director of the Vaccine Research Center at NIAID and pioneered a renaissance in vaccine development. And we'll hear from Gary about how that was the underpinning for the vaccines of the future. He's currently at Modex Therapeutics as the president and chief executive officer. Dr. Varmus, this is all yours.
Thank you very much. And I want to express my gratitude to the Clinton Foundation for featuring the NIH in today's event. I've had a lifelong engagement with the NIH as a trainee during the Vietnam War, as a grantee up to the present day, as a referee in other people's grants, as a consultant, and as you've heard from Donna, as both the NCI director in the Obama administration, and importantly for today, NIH director for most of the Clinton administration. For those on this call who are not so familiar with the NIH, I think I should begin with a few basic facts. The NIH has been in existence for over a century. It's a federation of today 27 institutes and centers, each of which receive their direct appropriations. The budget for the NIH today is about $43 billion. When the Clinton administration started, it was a little under 11 billion, increased steadily, and then initiated a 5-year doubling process, thanks to the support of the president and many others. The NIH is a health-related science agency. It doesn't do any direct health care. It provides basic and clinical research opportunities, training, and infrastructure to the nation's medical research establishment. About 10% of the research that is done by the NIH is done by government scientists, mainly on the campus in Bethesda. The rest done through grants and contracts to institutions and medical schools and universities in all states and some abroad. And these grants and contracts are issued, importantly, through competitive peer review. Like all agencies, NIH has annual appropriation, but it's important to note that the NIH does its research through multi-year grants and contracts and works on very long-term problems, which means that support from the administration to keep its budget strong is incredibly important. Ever since Franklin Roosevelt dedicated the new NIH campus in Bethesda in 1940, NIH has had a most favored agency kind of status. As both President Clinton and Secretary Shalala noted, we've had support at the NIH from both sides of the aisle for many years. And in general, we have a good working relationship with both the executive and the legislative branches. There are two ways in which the executive branch, especially the White House, provides comfort and support to the NIH during an administration. First is the support for that long-term ongoing work that supports the biggest medical research enterprise in the world. And during the Clinton administration in particular, there was strong support for many aspects of basic research, all of which can lead to improved health over many years, even many decades. And you're going to hear about how things that came to fruition during the Clinton administration and the treatment of HIV and AIDS. But there are many other examples that we could have been illustrating on in advances in cancer treatments and improved outcomes of cardiovascular disease and stroke and many other things. But there are also shorter term needs, health crises, construction projects, starts to new programs, expansions of others, like the Genome Project that we'll talk about in some detail in a moment. And in the Clinton years in particular, there was expanded work that we'll talk about in genome research and in vaccine production. But in addition, in areas we won't even have time to discuss, and concerning global health, rapid dissemination of findings through the advances that the president mentioned in information technology, through the development of PubMed and PubMed Central that disseminate the findings of NIH investigators to people all over the world. From my perspective as the NIH director during most of the Clinton administration, and as a scientist who's dependent on NIH all the time for my own work, I look back on the Clinton years as the golden years in medical research for many reasons. First, we had the enthusiasm of not just the president, but the president's family. Indeed, the first member of the family to come visit us was the First Lady, who came to the NIH for a day-long tutorial about genetic research and virology. And she then brought the president out for his Saturday tutorial just after giving a radio address about the Family Leave Act. He heard about the research going on in AIDS and genomics and cancer research. And that persuaded the first daughter to turn up and spend several days working in one of a lab run by one of our outstanding female scientists. We still have vials that are labeled CC1, CC2, CC3 for mutants of a bacterial protease that she isolated. The second reason is that is the strength of the budget proposals. The president said to me many times, I'm not proposing everything I want you to have, but I know that Congress is going to double your increase, even when Republicans are in charge. And he followed that prescription for many years and helped to start the 5-year doubling in 1998 that's had the effects that Secretary Shalala just mentioned. A third aspect of his support was the quality and attitude of our partners in the US government during during the administration that I've served in. With most obviously Donna Shalala serving as my good friend and supporter as Secretary of HHS, but also the appointment of Alice Rivlin to run the Office of Management and Budget, people like Jack Gibbons and Neil Lane serving as science advisors, Jack Liu and John Podesta serving in the White House. Other members of the panel who have been introduced to you briefly by Donna will illustrate some of the things about the Clinton years that remain incredibly important to the entire scientific enterprise. The first is how long-term science pays off. And you're going to hear from Tony Fauci about, who has been director of the Allergy and Infectious Disease Institute for almost 40 years, about how long-term investments in the studies of infectious agents, including HIV, have led to culminations of those efforts during the Clinton years, with our ability to prevent transmission of HIV from mothers to infants, the development of protease inhibitors, and development of highly effective therapies against AIDS. You're going to hear from John Gallen about an aspect of NIH renewal. When the Clinton administration began, the program that was run by government scientists in Bethesda was under some criticism, and a report from outside scientists arguing that one thing we needed to do was revitalize clinical research at the clinical center in the NIH intramural program led to a recommendation that was given due scrutiny by the Office of Management and Budget, and he'll tell us about the planning of the new clinical research center, named for Mark Hatfield, and the many new things that have been done there. And then you'll hear from Gary Nabel about how he managed as the first director of the Vaccine Research Center, which is a direct outcome of President Clinton's involvement in AIDS research. The then head of the Office of AIDS Research, Bill Paul, unfortunately deceased a couple of years ago, led to a proposal. We put together a vaccine research center on campus. And one day, the president and Al Gore had me and Tony Fauci come down and chat with him about what needed to be done in AIDS research. And he immediately bought on to this idea of building a vaccine research center and made that part of an address he gave shortly thereafter at Morgan State. And that persuaded Congress to proceed with an investment that, as you'll hear, is paid off in many ways. So let's turn this over now to other members of the panel, starting with Professor Fauci.
Thank you very much, Harold. And thank you, Donna. And thank you very much, Mr. President. It's such a pleasure and an honor to be here with you all today to celebrate the period of which we had such an extraordinary experience and accomplishment at the NIH during your tenure as president. In preparation for my very brief remarks about this, I just went through my mind the other day, almost on a year-by-year basis, the extraordinary advances that we experienced literally from the day you set foot into the White House. You remember one of the first things that you did in 1993 was to establish the White House Office of National AIDS Policy, or ANAP, which actually is still today exerting an important function. We never had that before you came into the White House. And then, though, it was also at a time when the toll of morbidity and mortality was accelerating in the country. And by 1994, AIDS became the leading cause of death of all Americans aged 25 to 44. But then things started to turn around with regard to therapy. You'll remember the famous ACTG 076 results, the first time that we showed that you could actually interfere with the transmission of HIV from a pregnant mother to the baby. That has to be one of the true hallmarks of iconic studies done at the NIH under your leadership as president. The years that really were so exciting, all 8 of them, but there was a cluster of a few in the middle that from my standpoint was transforming. From 1995 in 1996. And that's when we went from 1 and then 2 and then 3 drugs in combination, culminated by the first time of the use of protease inhibitors, which was the 3rd drug in the 3-drug combination. And what happened then was something that I have to tell you without hyperbole. Every time I reflect back on that, I still get little bits of goosebumps because I had been taking care of persons with HIV for those years from 1981 right up until the time in 1996, when that combination proved to be completely transforming and turning around the lives of persons with HIV. And the 1996 Summer Vancouver International AIDS Conference, those results were presented. You remember that, Mr. President, and it shook the world in a very positive way, because from that time onward, the idea of hospices was a thing of the past for persons with HIV. I also want to reflect on something that Harold mentioned. I have a photograph that I show at many meetings of Harold and you and I and Vice President Gore and Bill Paul in the Oval Office. I was presenting to you a schematic of a brand new discovery of a co-receptor called CCR5 for HIV. You got very wonky because you really wanted to know the details of what that receptor was. But at the end of the scientific discussion, you brought up what Harold had mentioned. You said, by the way, Tony, it's 1996, December the 3rd. We had HIV since 1981, and the virus was discovered in 1983 and 84. Why don't we have a vaccine? And that's when we got into the discussion of the possibility of having a vaccine research center. And you said you would do something about it. I actually thought you were just trying to be nice to us, but to our great surprise, in May of 1997, you announced at a commencement address at Morgan State that you actually were going to support the building of a vaccine research center at NIH. And you'll hear more about that from Gary Nabel. But the years went on and things actually got better and better. One of the things you did do that you started that led to the success in a subsequent administration of the PEPFAR program, but even as you were president, you issued an executive order to assist developing countries in importing and producing generic HIV treatments so that they could have available to them treatments that were costing tens of thousands of dollars here. And importantly, when you left the presidency through the Clinton Foundation, you continued that pushing to have the availability of drugs to people in the low and middle income countries. So it was an extraordinary run, and I'm so proud to have been a part of it with you. Thank you, Mr. President.
Tony, thanks very much. We'll come back to questions and answers in a moment for people to query you about some of those terrific anecdotes. Now we're going to turn to John Gallen to hear about events at the clinical center during the Clinton administration. John?
Well, thank you, Mr. President, for holding this conference. It's a real thrill to participate. The NIH Clinical Center opened in 1953, and since its opening, incredible teams of basic and clinical scientists, in close partnership with patients who were very courageous, often in the scariest moments of their lives, has resulted in outstanding history of accomplishment, improving the healthcare of the nation and the world. A few examples of early accomplishments include chemotherapy for cancer, the cure of childhood leukemia, lithium for depression, fluoride to prevent teeth decay, identification of cholesterol as a risk factor for heart disease, the first 3 treatments of AIDS, and the discovery of hepatitis viruses B and C that cause cirrhosis and liver cancer that led to a vaccine for hepatitis B and tools to protect the blood supply from and to treat hepatitis C. Dr. Baruch Blumberg received the Nobel Prize in 1976 for discovery of hepatitis B, and Dr. Harvey Alter from the Clinical Center, in partnership with Drs. Michael Houghton and Charles Rice, shared the Nobel Prize in 2020 for the co-discovery of hepatitis C. But 40 years after the Clinical Center opened, the hospital infrastructure was barely able to sustain modern clinical care and science, and the Clinical Center came under scrutiny. In 1994, a report on the NIH intramural program to the NIH director, Harold Varmus, by a committee chaired by Gail Castle and Paul Marks, recommended for the first time a new clinical center be constructed as promptly as possible. The same year, Vice President Gore's Reinventing Government 2 initiative said the clinical center should be critically reviewed and re-engineered to improve its effectiveness and efficiency. In response to this recommendation, the Department of Health and Human Services, under Secretary Donna Shalala, convened a team coordinated by Dr. Helen Smith to conduct a review. And the review reiterated the earlier recommendation to build a new clinical center. As a result, with the support of the President's administration and Congress, plans to construct a new clinical center were initiated. Key events in moving the process forward included President Clinton, your visit to the clinical center in August of 1995. In December of 1995, the architecture firm Zimmer, Gunzel and Frasca was selected. On September 30th, 1996, Congress approved funding for the new hospital to be named the Marco Hatfield Clinical Center. Construction began in 1999 and was completed in August of 2004. And on September 22nd, 2004, a patient speaker, the late Susan Butler, called the clinical center the House of Hope, highlighting what the clinical center means to patients and to the public. The opening of the new Marco Hatfield Clinical Research Center enabled the continuation of great accomplishments that continue to improve the health of the nation to today. These include cell-based immune therapy for cancer, new treatments for kidney cancer, a new drug for depression, ketamine, first in human studies for the Ebola and COVID vaccines, discovery of a new category of diseases called autoinflammatory diseases and new drugs to treat them, gene therapy for several rare diseases, including sickle cell disease, and the creation of the Undiagnosed Diseases Program, where patients from across the nation with unexplained medical problems are brought to the clinical center for evaluation and advice for treatment. In 2011, the clinical center received the Mary Woodward Lasker Bloomberg Award for Public Service for serving since its inception as a model research hospital, providing innovative therapy and high-quality patient care, treating rare and severe diseases, and producing outstanding physician scientists whose collective work has set a standard of excellence for biomedical research. What a marvelous gift, Mr. President, you and your administration and the Congress gave to the American public and to the world with the revitalization of the NIH Clinical Center. Thank you.
John, thanks very much for that really terrific summary of not just the clinical center itself, but stressing the importance of clinical research. It gets more important every day as basic science produces more products that need to be properly tested and evaluated in the context of what is the world's largest research hospital in the world. So we're going to turn now to Gary Nabel to say more about a topic that has already been introduced by a few of us, namely the Vaccine Research Center. Gary, welcome.
Thanks, Harold. President Clinton, it's really an honor and a pleasure to join you today, along with the powerhouse team that you had put together at the time that I came to NIH, Secretary Shalala, Harold, Tony, John. It's great to be reconnected on this occasion. You know, when we think back now to the AIDS crisis, as Tony outlined, as our memories fade, we sometimes forget the unimaginable toll that crisis took on human life. Not only the toll on human life, but the quality of life for victims and families, as well as the profound effects economically and politically throughout the world. More than 39 million people have died in the epidemic so far, more than 5 times the numbers that we've faced with COVID so far. And despite the gravity of the global health threat and significant investments in the science at the time, by the late 90s, despite the pronouncement from Margaret Heckler in the Reagan administration that that Tony and you alluded to, her pronouncement that we'd have a vaccine in a few months back in the early 80s, the vaccine remained elusive, and yet it will remain the best way to prevent and contain the epidemic. Now, the reason for it, obviously, is the biology of HIV. This is an insidious virus, and it posed an unprecedented scientific challenge for vaccine development. And the reason for that is because it had such enormous genetic diversity, and it also had the ability to camouflage many of its important viral entry proteins. There are more variants of HIV in a single person infected with the virus than there is in the entire planet and the whole population of the world during a single year of an epidemic like COVID or flu. So compared to licensed vaccines, where there may be 3 to 10 components at most, this complexity poses a really daunting challenge, one that thwarted the best and the brightest of scientists working in individual labs around the world. So it was really in this context that Harold and Tony and Bill Paul, with support from Secretary Shalala, approached you, and where you all decided that the best thing to do is to develop a dedicated vaccine research center to be built at NIH to overcome the scientific, technical, and early development challenges facing HIV and other emerging global health threats. As Tony mentioned, the room where it happened was the Oval Office of the White House. And I think it's important to note that this group that met there really served as a brain trust that not only started the process, but importantly remained involved and nurtured its growth. The Vaccine Research Center was an innovative model for the support of scientific research in 3 ways. First of all, it provided a physical place, a physical laboratory, whereby you could bring the best and the brightest scientists together in one research center, and where they could work in a multidisciplinary way to approach the problem, because vaccine development is highly complex and involves many different types of approaches. Secondly, it was a mission-driven research organization. We came to work each day knowing that a day saved in bringing a vaccine to the world saved 6,000 lives. Those efforts extended not only to HIV, but also as we worked at the NIH to other emerging health threats. The first SARS outbreak, avian flu, Ebola, chikungunya, Zika, and now COVID. And finally, it was a place where we could actually make clinical products and conduct human trials. And so it allowed us to operate independent of the constraints by the vaccine industry in undertaking vaccine development. And it's important to recognize that in large part, many of these vaccines are not developed because there's a failure of the private markets to address global health challenges. So it's an important model for public-private partnerships. The team at the Vaccine Research Center was carefully chosen, first to cover the spectrum of research, ranging from the intricacies of the atomic structure of HIV, to virology, to genetics, to immunology, to clinical trials. I should point out that there's so much synergy between the different efforts will talk about in both sessions today, ranging from genetics that allowed us to work rationally on HIV drug development and vaccine development in ways we could not have done without the power of human genome sequencing. Secondly, it allowed us to take advantage of the clinical center, and we in fact conducted multiple trials at the clinical center. Importantly, within the center, each investigator was picked not only for their scientific excellence and their expertise in these complementing areas of research, but also for their emotional intelligence and their ability to work together as a team. And that was really critical to the success. From my perspective, it was a dream team. Not only the scientists, but also the leadership. And I do want to particularly mention Tony's continuing involvement. Tony, I think you and I met weekly on the couch of your office for 14 years, and I have many fond memories of our scientific and our personal discussions over that period of time. Harold, same for you, except we met on the tennis court more than in the office. But what I will say is that the scientists on our staff, like Peter Kwong, an eminent structural biologist, John Mascola, a superb virologist and primate biologist, who succeeded me as the next VRC director, Rick Kaup, human immunologist, Nancy Sullivan, and Ebola vaccines, and Barney Graham, who led the clinical translation for advanced vaccines, including flu, RSV, MERS, and of course, most recently, the SARS-CoV-2. The center has succeeded in a number of ways. More than 100 clinical trials have been performed. Connections to industry have been made to make new vaccines accessible to the public. Perhaps the most tangible recent success has been its catalytic role in accelerating the development of the COVID mRNA vaccine. The VRC worked quickly internally and with industry to advance prototypes and to identify structure-based mutations that freezes the virus in a form that optimizes vaccine protection and gives us some of that protection that we're now seeing across diverse strains. And finally, at least from my perspective, the Vaccine Research Center is a gift that keeps on giving. The VRC has multiple productive collaborations with academic and biotech and pharma labs. There's now a diaspora of VRC scientists who have taken the training that they've received there and the spirit of the institution to new places where their work contributes to the continued preservation of global health. COVID vaccines have likely saved tens, if not hundreds of millions of lives. And the VRC contributed in a foundational way to its development, while progress continues to this day on HIV, Ebola, chikungunya, and universal flu. For me personally, it was an unparalleled and special opportunity to show how science and data can impact human well-being and save lives. To President Clinton, Secretary Shalala, Harold, Tony, your leadership and wisdom has achieved significant goals, and I'm confident there's more to come. So stay tuned, the work continues. And finally, I very much appreciate the opportunity to help build the center and to serve. Thank you.
Thank you, Gary. Tony, given the pressure everybody was under, you could have just made the vaccine center very narrowly focused on HIV/AIDS. But it seems to me that the decision to make it a vaccine center to cover more than just AIDS was absolutely critical for the future. Could you talk a little about that?
Yeah, well, thank you for that question, Donna. That is really an important issue. It became very clear to me and to Gary, who was the director at the time, that the talent that we had accumulated in the senior people and then their junior colleagues and acolytes was such that although we put a full-blown effort on HIV, particularly some of the things that Gary mentioned, the structural biology capability, the idea of structure-based immunogen design, it became very apparent to us, Donna, that that was applicable to RSV that was applicable to any of a number of viruses, that we did not want to constrain ourselves just to studying HIV. So we went into flu. We did coronaviruses with the first SARS-CoV-1 and then MERS. And then the particular interest that Barney Graham had in respiratory syncytial virus, which was his love before he even came there, actually ultimately partnered with Peter Kwong to develop the image design that led to the coronaviruses. So it was just a beautiful symphony of people who were playing together, and it became very clear that it would go well beyond HIV, which it has.
I'm going to make one footnote to that comment, Tony. Back in the very first days of the Clinton administration, when things were not going very well in the development of treatments and protections against AIDS, we had commissioned an outside group headed by a distinguished virologist, Arnie Levine, to evaluate the AIDS program. And one of the recommendations was that the development of immunology as a discipline was not being sufficiently applied yet to the study of HIV. And then Bill Paul, who had been director of the Office of AIDS Research, noted that we had tremendous strength in immunology, ranging from people like you, Tony, to many others on campus who could make a contribution to the development of vaccine research. And people on campus began to gather. And next thing we knew, we had a proposal for a vaccine research center. And I'm very grateful to the president for saying, this is not just going to be an HIV center. It was going to be a center for vaccine production. And it's proven to be incredibly valuable along the lines that you said.
Yeah, thank you very much. Many people think that that NIH is organized into silos. And it seems to me the Vaccine Research Center, the Clinical Center are two examples where the entire community of NIH came together. John, you would not have been successful if everybody hadn't bought in.
Absolutely. All the 17 centers and institutes that in the intramural program use the hospital. And they all interact very closely.
That's great. I think President Clinton wanted to make a comment here. Mr. President?
This was fascinating, hearing this from your perspective. I wanted to say, to me, you made a case that if we want to continue this, we have to get broad-based support. And I'll give you both within the Congress and in the larger country. In the Congress, Harold, I've always given you credit for this. I don't know if you deserve it, but if you don't, you'll give it to somebody else.
I'll accept it.
But, we got waxed in the 94 presidential election because I tried and failed to get healthcare reform, allowing the history of it to be rewritten. And because I tried and succeeded in getting the assault weapons ban, the 10-bullet ammunition clip limit, and the Brady bill passed. But I talked to Newt Gingrich one day, and he had 100 members of his new majority who didn't have a passport and were proud of it, and thought government would, mess up a 2-car parade, and the purpose was to have less of it. And I knew he was interested in science because he had given me a copy of E.O. Wilson's book on ants. And, he just died. He was a good man and a remarkable, wise man. So I said,
You're talking about E.O. Wilson, not Newt Gingrich.
Yeah. So I said to Newt, well, we gotta get these people on the research bandwagon. You need to take them to NIH. But when they got there, these people who thought the government was some sort of amorphous evil blob, whoever was responsible for the tour these freshman congressmen took started them in a hospital bed. And they lay in a bed and looked at the films, saying what all the NIH was doing on the TV in the hospital room. And it was an elemental political observation, which is that everyone wants to go to heaven this morning, but nobody wants to die. And we all want to live as long as we can. and it was brilliant. And all of a sudden, we had no problems getting the Republicans to vote for the NIH budget. The other thing I would say is we had a couple of years where the Christian evangelical community leaders basically were involved in mainstream politics, talking to everybody. I brought them in 2000 on the Millennial Debt Relief Initiative, and I had worked with a couple of them who were friends of mine, and they all supported relieving the debt of the world's poorest countries if they put the savings into healthcare or education or development. And President Bush later institutionalized this, but they weren't quite ready on AIDS yet. You know, they weren't quite past, we just got to talk about prevention and abstinence and nothing else. But by the time he got to the point where he had the votes in Congress because of their support to pass the PEPFAR program, which I loved. You know, we tripled overseas AIDS assistance when I was president, and we were giving 25 or 30% of what the world was giving, but it was peanuts, nothing. And so after he did that, I want to give him credit for something else that a lot of people don't know. In the beginning, they were only working, I think, in 7 or 8 countries because they were requiring PEPFAR to purchase for these countries medicine that Big Pharma was making, and they'd give them a discount, but it was like $1,500 a year, which was less than the $10,000 or so we were paying in Harlem, but way more than 150 or so we were already down to with the prices we had negotiated through the Clinton Health Access Initiative. So I was flying with President Bush to the Pope's funeral and flying home. And he said, talk to me about what you're doing on AIDS. And so I did. And I said, you know, you ought not to make these countries buy generic drugs, but you ought to give them the option to take the money you give them and spend it on generics if they want. And he said, well, I'm told that they're not as effective. I said, I know they tell you that, and I know they're important to you politically, but it's not true. I said, what if I were to submit to the FDA every single drug we put in any human body in any country for review and approval? If they get approved, would you okay the money? He said, it sounds like a fair deal to me. It was just the two of us talking. He didn't have, no lobbyists had a chance to talk him out of it. He just cared about whether poor people were going to live or die. And I could tell he really cared. And so we submitted 22, as I remember, 22 different products, and 19 were immediately approved by the FDA. And he didn't slow walk it. He didn't do anything. He played it totally straight. They just reviewed them and approved them. And all of a sudden, PEPFAR was in more than twice as many countries, treating a hugely greater number because he did that. And he had the support of the Christian evangelical community. So that's a good, both those examples show you why we need to keep working to build broad-based support for the work of the NIH. And our common humanity can sometimes be found when we're sick or someone we love has something wrong with them, and even when it's not available anywhere else. So, and I thank you. And Harold, I've always given you credit for putting those congressmen in the hospital bed. So
thank you, Mr. President. Thank you. Harold, it's all yours. The next panel.
Oh, thank you again, Donna. And we're going to continue the conversation very much in the same vein of talking about how science proceeds, how it works, how presidential support really helps, especially when it comes to getting increased allocations of funds for an important project, and getting the confirmation of that significance by having the president himself speak out on the importance of genomics. And indeed, we've just heard just a few moments ago President Clinton reminiscing about the importance of learning how much of our genetic heritage is held in common among people who seem to thrive on strife, as opposed to recognizing the 99.9% identity in one genome to the next. Before we launch into this more detailed discussion of the Human Genome Project, I want to issue a very brief reminder that genomics, like everything else, is built on prior work and work of the NIH and other organizations around the world for 20 or 30, even 40 years to develop the tools of molecular biology and genetics was fundamental to being able to put ourselves in the position of imagining the sequencing of a complete genome. And indeed, even the idea of doing a complete analysis of the genome was dependent upon development of technologies that many people around the world were working on, having a specific proposal initially from a revered cancer researcher, Renato Del Becco, a Nobel Prize winner, who made what seemed initially to be an outrageous proposal, that we do something as outrageous as looking at every nucleotide of the 3 billion pairs of nucleotides in the human genome, and then the vetting by the National Academy of Sciences, first steps being taken by the Department of Energy at Los Alamos, the establishment of an office at NIH in a prior administration, then the recruitment by Donna Shalala and Bernadine Healy, my predecessor, as director of NIH, of Francis Collins, from whom you'll hear just a moment. And in just a moment, it all set the stage for this remarkable acceleration of work on the Genome Project that went on over the next several years, leading to the culmination of the work in around the year 2000. And you're going to hear from 3 people about the importance of all this. First, from Francis himself, who was the prime leader of the program during the Clinton years as director of the Human Genome Research Institute, and how he worked with other agencies, the Department of Energy, for example, and international partners, including the Wellcome Trust and the UK, and many others in a large number of countries who participated in this remarkable global effort. And then you're going to hear about applications of the Human Genome Project from 2 individuals who were not engaged directly in the Clinton administration, but in some sense have, through their work, fulfilled the ambitions of the Clinton administration in its effort to accelerate the Human Genome Project. First, from Wendy Chung, who's the director of clinical genetics at Columbia, talking about how the Genome Project has influenced her attempts to diagnose particularly inborn diseases that involve changes in our genes, and how those patients are cared for. And then you'll hear from Charles Rotimi, who's currently the director of the Trans-NIH Center for Research on Genomics and Genomic Health, Genomics and Global Health, through the use of genomics and international work in that regard. So, Francis, if you would spend some minutes telling us about the experience you had in the Clinton administration accelerating the Genome Project, then we'll turn it over to the other 2 speakers.
Well, I'd be glad to, and thank you, Harold. Mr. President, Secretary Shalala, dear colleagues and friends, it is a privilege to be part of this event with people I admire so much. Yeah, I'm walking back the memory lane here to the fall of 1992. I had been hired by Bernadine Healy to come and lead the Human Genome Project at a time where, let's be clear, it was a little uncertain about whether this was going to work. A fair percentage of the scientific community was not at all supportive, thinking that this was just going to be a boondoggle. And then there was an election, and people began to say to me, did you realize that you were hired by the previous administration, and maybe you ought to be a little careful about whether you really have a job? Well, I need not have worried, because I got a call. I don't know if it was the day after the election or the day after that, from Donna Shalala saying, never fear. We really believe in the Clinton administration about this project. I'm going to be your secretary, and I will make sure that this project gets the attention it deserves. So I decided that was right, and gave up my professorship in Michigan and moved into the old nurses' dorm on the NIH campus, where, together with a very plentiful abundance of cockroaches, I began to learn how the government actually operates. and was happily joined a few months later by Harold, who lived in another apartment down the hall in the old nurses' dorm with Connie, his spouse. The good part of that was we did a lot of strategizing at night over red wine about what exactly could be done here as we began to bring molecular biology and genomics forward at the NIH in a way that showed such promise. And we knew we had wonderful leadership with Donna, and we learned just how enthusiastic the president was about genomics when he visited us on a Saturday and had the experience of hearing his questions, showing him how to dissect a human chromosome, and recognizing that we had a dream team to support NIH and to support the Genome Project. And that was good because, of course, the Genome Project began with a budget that was essentially zero before it got started, and it had to ramp up, and it had to ramp up faster than the rest of NIH, or it couldn't possibly do its job, inventing all these technologies and also figuring out how to actually do sequencing at scale. Something like 1,000 base pairs a second was what we had to get to. And when we started out, we were lucky to do 1,000 base pairs in a day. It began to pick up speed. Secretary Shalala decided in 1997 that the National Center for Human Genome Research could be upgraded to an institute, as it now is today. Thank you, Donna, for that. And it was international from the start, and that was a big part of what it made possible to go at this pace with partners in 6 countries and 20 labs, all agreeing to work at the same set of guidelines and standards for excellence and accuracy of the data. And a very important decision made about that time that this data ought to be in the public domain. This should not be something as our shared inheritance that anybody owned. And so we began putting that sequence into the public domain every 24 hours. President Clinton strongly agreed with that. There were other entities that were claiming bits and pieces of the genome and trying to file intellectual property and sometimes getting it on those. And so in the spring of 2000, President Clinton and Tony Blair put out a statement saying it would be a good thing for the genome sequence that belongs to all of us to be accessible to everybody. Well, Joe Lockhart, in his press briefing that morning, didn't quite get it right. And I think he said something like, well, gene patents aren't going to be allowed anymore. And the stock market crashed, which was a little embarrassing. But fortunately, it all got cleared up fairly quickly. And it was a deep dip that was then retrieved and brought back into the better place, although I think some people in biotechnology were a little shaken up by it. Well, about that time, we had this race that the president was referring to with a private sector effort called Celera, led by Craig Venter. It was getting a bit unseemly. Both the public project and the private project were making progress. I asked Ari Petrinos, who was running the Department of Energy's effort in genomics, to convene Craig and me for pizza in his basement. And many essays and articles have been written about that pizza party, and there was more than one. And the result of that, a memorable day, Mr. President, June 26, 2000, East Room of the White House, with the scientific community and the world kind of gathered to see what this was, as we announced a not complete yet, but a very good draft, about 90% of the genome. It was the milestone that many people had been waiting for. Mr. President, you referred to the map that Meriwether Lewis had presented to Thomas Jefferson in that same room. Well, that was pretty interesting as a parallel. And I went back and read your remarks. You called the genome the most important, most wondrous map ever produced by humankind. And it was the language in which God created life. And you emphasized how all humans, regardless of race, yes, are more than 99% the same. And we all knew that you were quite attached to that, having noted how you had lectured the Serbs and the Croats in Kosovo, that they really shouldn't be fighting with each other because their genomes were so similar. I'm never quite sure how that played out, but I thought it was a wonderful way to put forward some science at a difficult time. And that was such a moment. And we got to the end of the speeches, and you closed with this ad lib, and for some reason it just stuck in my mind, so I thought I would read it again. You said, when we get this all worked out, and we're all living to be 150, young people will still fall in love. Old people will still fight about things that should have been resolved 50 years earlier. We will, on occasion, do stupid things. And we will all see the unbelievable capacity of humanity to be noble, this is a great day. It was a great day, Mr. President. We crossed into new territory that day. But just before finishing, I'd say there's another day that I'll remember about 6 months later. There was a farewell in the Indian Treaty Room for the President and the First Lady. Interestingly, right now my office in the EEOB is right down the hall from the Indian Treaty Room, because I'm now serving as the acting science advisor to President Biden. I got an invitation to this farewell to the President and the First Lady, and from Chris Jennings. And I thought, I have to bring something. And the timing was just right. I brought the first CD that contained the human genome sequence on something you can hold in your hand. And I made a brief presentation. We were finishing the Nature paper that described this, which would have got published about a month later. And in that paper, which I had a lot of time devoted to trying to say something that was, well, maybe even a little poetic, it ended with T.S. Eliot's famous words from Little Gidding: "We shall not cease from exploration. And the end of all of our exploring will be to arrive where we started." And then the First Lady finished the quote for me: "And know the place for the first time." Yes, we know the place. It's a textbook of medicine. It's a parts list. And it's a record of our history. Genomics has expanded beyond anyone's dreams and expectations since then. The Human Genome Project took 13 years and $3 billion. Now your genome can be sequenced in a day for less than 1,000. Applications to cancer, birth defects, drug discovery, gene therapy, infectious disease, including COVID, have massively extended our reach in science and medicine. And there is much more to come. And for that, I turn to the next two speakers, beginning with Dr. Wendy Chung.
Thank you. I'm so privileged to be here, President Clinton. As I was listening to speakers today, I would say I'm actually a product of much of what they spoke about. I actually began my career scientifically as a student at the NIH Clinical Center, and NIH was inspired to become a genome scientist. I started out my training literally the year the Human Genome Project started, and realized, as Dr. Collins said, if we're putting that much money into this, there's going to be amazing things that we're going to be able to do, and was able to start dreaming about the day when we would be able to actually sequence our genome within a day. Just to give you a sense of where we are, as I look back, of those 20,000 genes that we now know of, there are remarkable 7,000 of those that we can now associate with a very specific human disease. And in fact, these conditions are quite common. Individually, many of them are rare, I'll grant you that, but collectively, if we look at many of these Mendelian conditions, 10% of us actually have or will have manifestations of these conditions. And I, as still a practicing physician, see a lot of these patients that are at risk, for instance, for hereditary breast or ovarian cancer, but they're able now today to be able to walk a different path than their mothers walked, or for those at risk for colon cancer, to walk a different path than their fathers have walked. They're able to see that they're at risk, and they're able to do something about it. They're able to take that into their hands and not let that be their destiny. They're able to really rewrite by seeing what's ahead, and to be able to take very conscious and deliberate actions, sometimes very brave, but to be able to lead a different life and to be able to lead a healthier life. They're inspiring. They are incredible in terms of what they personally do with this information, but there is so much more that's yet to come. It's been remarkable for me to be able to see that technologically, we can read out those 3 billion base pairs. We can do it for less than $1,000, but we had to overcome other hurdles. Sometimes this has been referenced, even legal hurdles, to be able to take down gene patents, to be able to have the ability to know that information content, and to be able to use that to take care of ourselves. As we've done, and I did it just yesterday in the neonatal intensive care unit at our hospital, we can take babies, for instance, who are critically ill and be able to read out their genome, just in some cases, hours to days, and be able to make critically life-threatening decisions about how to save their lives in some cases. Some cases where we'll need to be able to do an emergent transplant of an organ to be able to take care of a body part for them that is failing them. In some cases, to be able to give them medicines that are now tailor-made for their particular cystic fibrosis mutation, or as you'll be hearing in terms of gene therapy, to do some remarkable things that we're just beginning to think about for certain types of immunodeficiencies or certain types of hematological conditions like sickle cell. I'll tell you one story that really has made a big impression on me in terms of what is yet to come for us. When I started medical school, the most common genetic cause of death for children less than 2 years of age was a tragic condition called spinal muscular atrophy. And I'm using intentionally the past tense, used to be the most common genetic cause of death. It was heart-wrenching for me to see these children because many of them with the most severe form of the disease wouldn't live to see their first birthday because they were so profoundly weak that they could not breathe. They could not be able to inspire, to be able to take a breath. With time, though, and with a lot of this very foundational work that came from the Human Genome Project, from the science that came with it, we've learned that there are, in fact, not just one gene, but also a backup copy of that gene called survival motor neuron. And being able to use the technology to co-opt that second gene, we've been able to think about creative ways to be able to tweak it, to be able to upregulate it, to be able to use it, to be able to compensate for the deficiency that those children have when they're born. One of the remarkable things that we've done with that is to actually, in tandem, develop methods of being able to identify those children as newborns. So at this point, we can now actually, from a heel prick, be able to identify those newborns who are going to be at risk for spinal muscular atrophy, a progressive degenerative disease that otherwise would have taken their life, and now be able to use either gene therapy or one of 3 FDA-approved medications that is now life-saving for them. So that as we've been able to do that, and for this condition, which is an equal opportunity condition that affects all different individuals from all different parts of the world, now to have a completely different outcome for them, hopefully to be able to give them long, full, and healthy lives. That particular scenario, to be able to go from knowing that condition, diagnosing it in newborns, coming up with treatment, we did in record time. Really just a matter of 4 years that we were able to compress that with the diagnosis, rapid diagnosis, and getting those treatments, those 3 treatments, to now be approved. And I'm convinced that these are things that we can do over and over again with the foundation of this technology and with the industry that's been developed to be able to use this. Important to me, and I'll end with this, is just as this comes forward, what we did with spinal muscular atrophy was so important to me from an equity point of view, that as I alluded to, we were able to take a drop of blood from a newborn and be able to understand what conditions they would be at risk for from a public health point of view, where we could do this for every single baby. And it mattered not where they were born, who their parents were. Every single baby would get the same access and does get the same access to this phenomenal care that we can provide them. And that, I think, is going to be one of the things in terms of the future of what the Human Genome Project will have produced, allowing every child to have an equal, healthy start to life by using that information to be able to keep them safe and keep them healthy. It's been remarkable to be with you today. I'm honored.
Harold, you're muted.
Hello? Yes. Okay. Thank you very much. It's really an honor and a privilege to be a member of this panel and to be invited by the President Clinton's Foundation. I want to start by saying today is my birthday, and I can't think of any other way but to celebrate it with President Clinton and this wonderful esteemed panel. So again, I am in celebratory mood, and I think my parents who gave birth to me in Nigeria some 65 years ago, and I just qualified for Medicare, will be extremely proud to see me on this panel. My comments today really will be to emphasize how we can continue to ensure that the gains of the human genome is indeed accrued to all human populations around the world. It was a great honor when I was invited by Francis Collins and others to participate in a spin-off, the very first spin-off of the sequencing of the human genome, and that is the International HapMap Project, which was indeed very important because apart from knowing the addresses of the 4 combination of letters that make up our genome, we needed to know how these vary between individuals, between families, and also between ancestral populations around the world. And scientists realized that it is only by knowing these differences and similarities that we will be able to really fully understand how the signatures of the environment that our ancestors lived shaped our genome, and how that varies and how that influences disease and human health around the world. So the engagement of African population in the HapMap study, especially firstly the Yoruba community in Ibadan, Nigeria, was truly the first major effort to engage African communities in the human genome, and how we can indeed bring all global populations to bear on these wonderful success stories that was indeed funded under the Clinton administration. The HapMap project, also was, again, like I said, my first opportunity to be a part of this major initiative. But what the HapMap showed to us, and I just emphasize the point that President Clinton made earlier in his comment, and that is when we look at the diversity and the magnitude and scope of human genetic variations, we come to the conclusion that Africa populations has the highest diversity in the world. And that is not a coincidence. That is based on our evolutionary history. African populations, or human beings in general, have lived the longest on the African continent, and therefore have had their genome, have had more time to vary within that environment. And the point I'm making here is that there are aspects of our genome that we can only study by looking at African people. So I want to say that studying African populations and other global populations is a social justice issue, but more importantly, it's a scientific imperative. We cannot truly appreciate the scope of human variation without going to the roots and the cradle of humanity. And this is why I say sometimes that beneath all of our skins, we are indeed Africans. If we treat our history far enough, most of us, or if not all of us, we end up somewhere on that geographical location called Africa today. So it's critically important that we engage the African community. It will benefit Africa, but it will benefit the world even more. So this is why under the umbrella of the African Society of Human Genetics, and working with Francis Collins and other African scientists, we were able to establish what we call H3 Africa, Human Hereditary and Health in Africa, that has brought over $200 million to change the participation of African scientists and African population in human genetics. This was funded by the NIH with Francis Collins as the director, and also the Wellcome Trust Foundation, in the UK. Now, this initiative was unique in the sense that it actually enabled African scientists to fully participate by giving them the money directly to African institutions and to African investigators. And it has led to the creation of Pan-African laboratories, biorepositories and bioinformatics hubs that is changing the way African scientists are participating and informing the Human Genome Project and its success stories as it continues to be. We are now in a position where we can cure diseases like sickle cell using gene editing. So that is remarkable. African countries are also using the gains of the Human Genome Project to inform essential drug lists, all the way to HIV in places like Botswana, and understanding genetic variation in terms of drug metabolizing for something like codeine in Ethiopia. So you can see the gains are beginning to accrue. But what is important here is creating opportunity for African scientists to be a part of this wonderful initiative and to ensure that tomorrow's medicine will indeed be available to all humanity. We are indeed all come from the same place. And we need to share this, that our diversity is not an illusion, but we should not use it to re-emphasize old prejudice. Thank you for inviting me. Really glad to be a part of this effort.
Well, thank you very much for those interesting remarks. President Clinton began our discussion of genomics at the start of the session by emphasizing how much of the genome is held in common and how what we're learning from genomics can be a way of trying to bring the world together and make it a safer place. I think we're learning too that the diversity that you refer to and the pathogenicity of certain variations in the genome can be the source of disease, as Wendy pointed out, presents a challenge for all of us to be sure that the fruits of our research are widely shared in Africa and Asia, South America, everywhere in the world. And in the few minutes we have remaining before we wrap this up, I'd be curious to hear from any of the three of you about ways you see that that our existing institutions and scientists may have more of an effect on providing open access to the fruits of genomics. I know that just my own work with the World Health Organization over the last several months, that there is a receptivity to the idea of sharing genomic technologies, even in the poorest countries, and to be sure that, as has been illustrated during this pandemic, that the technologies that have been developed partly in response to the pandemic, are influential in saving lives.
I'll just quickly respond. I think, Harold, you're right that we have a great opportunity here. And with projects, Charles mentioned H3 Africa as a start on this, where the goal really is to enhance research capacity in a sustainable way in low and middle income countries. That is the best possible way to place the kind of capabilities in the hands of those who will need them in their own countries, and also perhaps to stem the brain drain, which otherwise has been a really serious issue for losing the talent that you want to have maintained. And I'm excited to see how that is taking shape in sub-Saharan Africa, although we've got a long way to go. We need to come up with even better ways to provide some kind of a partnership with industry, with NIH and the Wellcome Trust and other philanthropy organizations. But we need to get countries in Africa to recognize that this is time for them to invest as well. We need to go from what I would call donorship to ownership, where ministers of finance recognize that one of the best things they can do for their economy, for their people, is to put some money into research and development, because it will pay off over and over again. And we're kind of making that case and starting to get, I think, some receptivity, but that's what it's going to take.
Yeah, I agree entirely with that. And that the World Health Organization is going to be participating in that as well. And I think in many ways fulfilling the kind of ambitions that President Clinton and many others have had since the inception of the Genome Project, that this is something that can help unite humanity, and as opposed to tearing it apart. And we are approaching the end of our session here. And I did want to reflect just for a moment on the incredible privilege it's been for many of us to serve in the Clinton administration when things did move ahead so swiftly at the NIH, not just in elucidating genomes, but in improving our understanding of how the human body and many other organisms work, and how the studies of biological systems from many perspectives can lead to improvements in our understanding of disease and our efforts to create new therapies for diseases like AIDS and cancer and cardiovascular disease and many others. And I think it's useful for all of us to acknowledge our appreciation for the respect that the president in that era, President Bill Clinton, had on the country's appreciation of science and the efforts that the scientists are making to improve human welfare. And now it's my pleasure to turn this over to a woman that President Clinton mentioned at the outset, the new dean at the University of Arkansas Clinton School of Public Service, Victoria Soto, to make a few concluding remarks. And I want to thank all my fellow panelists.
Thank you all for spending your afternoon with us for this 32nd installment of the Kumpuris Distinguished Lecture Series. I'm Victoria DiFrancesco Soto, and I'm the Dean of the Clinton School of Public Service. Please join me in thanking the Kumpuris family. Your special gift has been so impactful, and we are forever grateful. A big thank you to Kevin Thurm and the Clinton Foundation. Thank you for your continued partnership and your support in this series. And to President Clinton, a very big thank you to you for joining us today in laying the groundwork for these successes, as well as laying the groundwork for the Clinton School of Public Service, a space where we're able to train our next generation of impact makers, our next generation of public service leaders, where we're able to bring first-rate, rigorous classroom instruction and marry it to on-the-ground service learning training. Thank you all for spending time with us, and I look forward to seeing you at the next installment of the Kumpuris Distinguished Lecture Series. Have a wonderful rest of your day.